Good morning. All right, today we have got a new starting a new unit. It is building off of what we've been doing. All right, so we're still going to be factoring. So we need to get practice with factoring, super important. Something that we're going to be doing a lot of. All right, and especially even as you go into integrated 3 eventually, and if you do math beyond that, factoring is something that you will need to know how to do. So we're going to keep practicing it. All right, so first of all, the big difference this time is that now we are actually solving for x, right? Now there is an equal sign in the equation, and now we are actually figuring out what is x. We're not just factoring some expression. Now we've actually got an equation, right? Equation has an equal sign in it, and expression does not. All right, so first of all, here's what we're going to do. We've got quadratic equations, right? Notice now we have an equal sign in them, and we can factor them. And this is the idea that we're going to use, is if two things multiplied together make 0, right? This is saying one thing multiplied by another thing. If that equals 0, then we've got two options. Either the first one equals 0, or the second one equals 0, right? Because the only way to multiply two things and get 0 is at least one of the two things has to equal 0, right? Because if I multiply two numbers that are not 0 by each other, I'm not going to end up getting 0. All right, so here's the general steps, and we're going to get a lot of practice with this. The first thing we're going to do is set the equation equal to 0. And then we are going to factor the quadratic side. So basically it means get everything on the same side of the equal sign. That's step number 1. Notice in these examples, they already are, right? This one's equal to 0, this one's equal to 0. So step 1 is already done for us on both of these examples. Step 2 is we're going to factor. That's what we've been doing the last unit. And then these steps down here, that is the new steps. Now, I will say these steps are a lot easier. I know there's 4 of them, and it looks like factoring is just getting it started, but not really. Once you factored, you're really almost there. All right, so let's do this. Well, first of all, we're going to factor this guy. We're going to do number 1, and we're going to work through all the steps. So number 1, we can check off. It is already equal to 0. So we're on step 2. We need to factor the quadratic side. So that basically just means the side where all the stuff is. All right, so let's factor that. So we've got, if you want to remember what we did, there's an invisible 1 right here, right? When that first term has the 1, that's the easy way. All we're looking for is two numbers that multiply to C. They multiply to -6, and they add to B. Now remember, that's an invisible 1, so we're adding to 1. All right, so first of all, notice we are multiplying to a negative, right? That means we need one positive number and one negative number, right? That's the only way to multiply to a negative, is if you've got a positive and you've got a negative. All right, so we're going to think about what multiplies to 6, and we can, with one positive and one negative, are added together to get 1. Well, with 6, we've only got two options. We've got a 1 and a 6, or we've got a 2 and a 3. 3 and 2 are combinable to get 1. And specifically, the 2 is going to be negative, right? Because 3 minus 2 is 1. All right, so just like we did last unit, we've got our factors, x plus 3 and x minus 2. All right, this is where that zero product property comes in. Now we've got two things right here multiplied together, and they equal 0. Right, so that means one of them is 0 or the other one is 0. All right, so we're going to go to step, so we factored, and we're going to go to step 3. We're going to set each factor equal to 0, just like this. And then solve, right? So we set them equal to 0, and then we're going to solve. Well, actually, we haven't solved yet. I won't check it. So we solve. We're going to subtract 3 on both sides, and we get x equals -3. And then for this guy, we can add 2 to both sides, and we get x equals 2. All right, so our solution set. So if we want to write a solution set, personally, I am okay if you just stop right there. That is all the answers that you need to give, right? We've solved for x, or we could write it as a set. We could say it is the set containing 2 and 3. All right, so we've solved and we wrote it as a solution set. All right, so that's the extra step, right? Is once we get those factors, you're just going to set each factor equal to 0 and then solve it. And those are going to be pretty quick, straightforward little algebra problems. They're usually like 1 or 2 step equations, like from integrated 1. And that's all there is to it. Now, as far as the check, this is the idea, is that if we want to make sure that we didn't screw it up, we can take these numbers that we got and plug them into x in the original equation and make sure that it comes out accurate, right? So if I wanted to plug in, I'll show you one of them. So I'll show -3. So if I plug in -3 into my original equation, right? I've got my original equation. And then for x, I'm going to plug in -3. And then for x, I'm going to plug in -3. Right? Notice nothing else changes, right? It's direct substitution. My squared stays there, the plus sign stays there, the minus sign stays there, the 6 stays there. The only thing I'm doing is that I'm substituting -3 for x. I'm substituting, so the x isn't there anymore. All right? So -3 squared is 9, and then -3 minus 6. So 9 minus 3 minus 6 is 0, and yes, that is true, right? So that's really all there is to it, and you can check it with the other solution as well. The purpose of checking is just to make sure that you did it right. And yeah, that's all there is to it. I'm not making too much of a deal out of checking. I'd say maybe you can check 1 or 2 of your answers, and beyond that, just do the work, right? Because generally in algebra, we don't check every single thing we do. On a test, it's a good idea, because it can help you make sure that you're doing it right, and especially if you have extra time at the end of a test. Because I know some people will finish early. If you finish early, I did this as a student. It helps you a lot. Just go through and check your answers, and this is how you check it. And that way you can catch mistakes and get points, and saves you from having to like try to do a retake later, stuff like that. Anyways, all right. So let's go through these steps again with this guy, number 2. The first thing I notice is that 2 goes into every single one of these. All right? So we can divide the entire thing by 2. And I recommend that. Look for common factors, because when I divide the entire thing by 2, it's going to make this lead term, that 2 there, it's going to make that become a 1, which is huge, because it's going to make the factoring a lot easier. All right. So let's divide everything by 2. We're going to divide both sides by 2. Divide that by 2, divide that by 2. So 2 divided by 2 is 1x squared. 4 divided by 2, that becomes a -2. And then 48 divided by 2 becomes 24. 0 divided by 2 is just 0. All right, now it's a lot easier to factor, right? So again, same thing we always do. We want to multiply to this guy and add to this guy. And those two numbers, again, we're looking to multiply to a negative, so you need to have one of each. And that's going to be, think about what multiplies to -24, adds to -2. It's going to be a +4 and a -6. All right, and then we're going to do the same steps. These are like the additional steps that we're doing relative to what we were doing in the last unit, because now we're actually going to solve for x. So we're going to take each of those factors and set them equal to 0. Set that guy equal to 0. Set this one. And again, these are just one-step equations, right? Subtract 4, you get x equals -4. There you go. And then we are going to add 6. We don't really need the equals there. We're going to add 6 on both sides, and then we are going to get x equals 6. There you go. Those are your solutions. And again, we can check them. I'll check this one. In theory, you would check both of them. To me, I'm not going to make a big deal out of checking the solutions. The main thing, it's if you want more practice and you don't feel quite comfortable with your factoring skills yet, maybe you want to check. But if you're really confident and you know that you're factoring them right, the main thing I want to see is practicing this actual skill rather than checking. All right, but here's how you would check, right? So I'm going to take this equation. Notice that wherever there is an x, I'm going to put a 6. So 2x squared becomes 2 times 6 squared, minus 4x, minus 4 times 6. And then minus 48 equals 0. All right, so do exponents first. 6 squared is 36, so we got 2 times 36. 4 times 6 is 24, minus 48 equals 0. 2 times 36 is 72. And if you want to grab your calculators, you can check that. Sure enough, this stuff is equal to 0. So we get 0 equals 0. That's true. So the check works. We could also do the check on the -4. I'm just a little bit out of room, and I don't want to dedicate this entire video to plugging stuff in and checking when the main purpose of the actual topic is the stuff we're doing over here. It's all of the factoring and solving. All right, we got some more examples here. So some of these I'll just show you the first step because they're very similar to what we just did. Otherwise, we're going to end up with like a 30-minute video. What I will do is I can create answer keys, and during class, you can text or email me questions about like, hey, what's going on with number 7 or number 8 or whatever, and I can send you all the steps and explain all the steps. All right, otherwise it would be a super long video. Okay, number 3. Remember that very first step that we talked about on the previous page is that we need to get this whole thing to be equal to 0. Well, right now, all this junk is not equal to 0. It's equal to 5. So we need to get it equal to 0. How are we going to do that? Subtract 5 on both sides. And notice when I am subtracting 5, we're combining like terms. I'm subtracting it from the 30. Not from the x squared, not from the 10x, because there's no x on that 5. So we're subtracting it from the 30. So we're going to get combined like terms and get x squared plus 10x plus 25. All right. And then from there, you're going to factor it. You're going to think what multiplies to 25 and adds up to 10. So you'll get x plus 5 times x plus 5, right? Because 5 and 5, they multiply to 25, add to 10. And then we're going to set them both equal to 0. Set them both equal to 0. I'll rewrite this one because that came out. But notice, right, these are the same thing, right? So we're only actually going to get one solution this time. They both give us the same solution, and that is -5. And that's fine. Sometimes if they're a perfect square, once you get everything on one side, right, that means if both of our factors are the same, we're only going to get one solution. Because when we set them equal to 0, it gives you the same number. Cool. All right. Number 4, what do we got? 4 and 5. Actually, 4, 5, and 8 all have something in common. We'll see what that is in just a second. All right, so there's a couple ways to go about this. What I personally think is the easiest way is if there is only one term with an x. That is the case in number 4. It is also the case in number 8. Not in number 5 because they both have an x. All right, but 4 and 8, there's only one x. What I say to do is just solve for x the way that you're used to solving for x. So we actually don't need to factor here. All right, so we're just going to get x all by itself. So add 16 to both sides. And you're going to get 16 equals x squared. Right, and we want to get x by itself. So we're going to take the square root, opposite of squaring. So we're going to take a square root on both sides. And that is going to give you, whenever you take the square root on both sides, it is a plus or minus. So x equals plus or minus 4. All right, something super important to remember. Whenever we take the square root on both sides, it is a plus or a minus. All right, so if they're like this is on a test, that'd be like half a point right there probably. So make sure we include that. Number 8, I'm going to do that one next just because it's similar, so that way we can kind of see a pattern here, is there's only one term with an x, right? There's an x here. There's no x on my other term. So I'm just going to solve for x. So we're going to divide by 4 on both sides. And you're going to get x squared equals 9 over 4. And again, we're going to take the square root. So always get the x by itself. Do that first and then take the square root every time. Get the x by itself, then take the square root for these types. And whenever you've taken a square root of a fraction, take a square root of the top, the square root of the bottom. So pretty straightforward. So the square root of 9 is going to be 3. The square root of 4 is going to be 2. So notice square root of the top and the square root of the bottom. That's all you got to do there. And then again, we did take the square root, so there's going to be a plus or minus. All right. Let's see what else we got here. Number 5 is the next closest. All right, so notice there's only 2 terms right here, one on this side, one on this side, but they both have an x. So we can't solve for x in the same way. So we are going to factor, but we're going to be looking for a greatest common factor here. All right, so here's what we got to do. Subtract, I would say, whichever term has the x squared, you want that one to be positive. So if it's already positive, move everything over to its side. If it's negative, move it over to the other side. It makes the factoring way easier when the term with the x squared is positive. All right, so notice it's already positive. So we're going to move this guy over here. So we're going to subtract 15x on both sides. So that gives us 3x squared minus 15x equals 0. Right? Notice I can't combine these two. They are not like terms. They don't have the same exponent. Right? This is a squared. There is not a squared here. So I cannot combine these. So when I do 3x squared minus 15x, that's all there is to it. My whiteboard just glitched out. I'm going to stop and make a new video.